Um, I am still working on grading that quiz. I'm pretty good about grading, but just didn't quite get to it this past weekend. So my goal is to grade that today. Have that up there later today. We can look at that on Wednesday. I know that some people struggled on that with the limit definitions, and we can look at that together. I'll get solutions posted too. I do have solutions. I'll just throw them up there today, so at least you can start looking through that and thinking about questions you might want to ask on Wednesday. Got the, I had this up here. Did that stop sharing? Let me go ahead and share my screen again. And just remind you of this weekly schedule posted. And I'll just point out, just trying to point out that there's a lot of problems due this week, but 17 of them are from the chain rule. There's 3 homework assignments, right? 17 of them are from one called chain rule, which is what we're in the middle of now. It's what people oftentimes are find to be the most challenging rule. And so I'm happy to extend that one in particular. Probably not the other 2, but that one in particular we can extend either to Friday or next week potentially, but I do want people to start looking at it. So, we're working on that material. You should be able to sort of complete that one by Wednesday, but if we need some more time, I'm happy to extend that one. Just be aware, because 40 problems is a lot. That's probably the most we'd have in any given week. And so at least close to half of those can be extended. And yeah, moving forward, we've got our next test kind of on the horizon. It's not, it's not super soon here, but just be aware that in a couple weeks, so not this Friday, not next Friday, but the following Friday, we'll be looking at our next test. I'll start working on topics and stuff like that, but we've got a bunch of more material to cover, obviously, before that anyway. All right, how's everyone doing today? If you guys have any questions about anything in particular that you want to look at before we keep looking at the chain rule, and we're just going to be digging into differentiation rules quite a bit. I had extended that homework last week till Friday, so I don't know if people wanted to look at some of those homework assignments from the power rule one or anything there.
Yeah, can we look at problem 4?
This one? I think we looked at this one together, I think, potentially. What was tripping you up about this one in particular? Because it's very similar to a lot of the other ones.
I just realized I was muted. It's the problem 4 for product quotient.
Oh, okay.
Sorry.
Okay. Yeah, this is a good one. So I actually just purchased I'm doing the trial technically, but I just doing the trial of this paid version of this app. So hopefully I can do things a little easier in here right now. Although I just did that, nothing happened. So what the heck? Maybe it's taking a second. Oh, and then it crashed. So that's not good. So that one, cool. Okay, it did come over here. And then can I do stuff like this? I can convert it to a PDF now, and then I can just easily do stuff like move it around, I think. Okay, anyway, let me read this one. Okay, so we've got our h function, and we're saying it's the product of 2 functions, just the same function twice, basically f, right? And we're given information about the function value and the derivative. Now I see. And so this wants h prime of 1, right? So this basically is asking us to compute h prime of x and plug in x equals 1. Is that okay? That's sort of like what we need to do, right? And since it's a product, we're going to use the product rule, right? And obviously it's the product quotient rule homework set, so that shouldn't be too much of a surprise. But when we do h prime and we do the product rule, it's going to be f prime f plus f f prime. And that's because, let me go ahead and open up the product rule real quick in case we need to just see that. I'll just remind you again, it's a good idea to have this out in front of you. I can't constantly be switching back and forth. We got to start having this out in front of you, right? But here's the product rule, and we're just applying that. But in this particular case, we have the same function. So f is g in our example. And so instead of having like an f and a g, we're just going to have f and f prime, right? And so this is literally what I just wrote down on that last page. Let me swap back over there, right? F prime f prime f plus f prime is the product rule. And now we just want to plug the 1 in there, and we have all the information about that, right? So h prime of 1 is going to be f prime of 1, f of 1, plus f of 1, f prime of 1. Right, and we have all that information up top. I'll let you finish this one, but you can just plug those things in here, right? Is that okay, Gregor, or anyone else?
Yeah, I get it. I did do that. I must have messed something up.
Yeah, so it's gonna be the same thing in both cases, right? So it'll be -9 times 5, which is what, -45. Add them together, so it should be -90, I think. And well, this is actually someone else's problem in this case. I don't. You have to double check that. Double check your math, yeah. This is actually Andrew's problem randomly. I don't know why I'm acting as Andrew, but I don't see him in here. But Andrew, if you're listening, this is yours. This one's okay. Are there homework questions? How can I move this? The question is, did this become easier? Let's find out. So I go to recent files. I don't know if that became any easier. Sorry, just give me 1 second. I'd love to be able to figure this out and just be done with it. Yeah, I'm not sure. I'm just going to leave it open and I'll figure it out later. Other homework questions? Anything? Check the chat here. No. Okay. So we were in the middle of the chain rule, and because I'm now on my iPad doing things differently than I'm used to, I've gone over top of this second example, and so I was going to insert a page here. And it might just be good in general. You may not have enough room on this particular page for your writing. You might want to have like a blank page to insert here, just so you can add enough notes for yourself to make this understandable later. So, you know, this one right here, I'm going to go ahead and do on another page, but maybe we can finish some other ones on this page and then collect the ones that we missed and put them on another page. My goal here today, a little bit at least, is to do several examples of the chain rule, let you think about them yourself, one or two by yourself. And then there's just like not tons more, but there's an entire more page of additional examples that really start to combine all these rules. And honestly, the examples on this page 29, if you can do these examples, you kind of have a good understanding, I think, of all these rules. That's sort of where we're heading. So, we're really just starting to combine things is what I'm trying to say. So please, please, please just be active, be taking notes, be sort of thinking about this as we go. And if it's not clear, let me know. All right, I'm going to dive in. There's nothing else you guys want to chat about? Quick. Got a lot of people here. Great. Okay, so real quick, we're doing the chain rule, right? This is one right here. It's when we have composition functions. And so it involves one function inside of another function. And so it involves identifying those two things and then looking at their individual derivatives. And it kind of presents itself in a kind of confusing way. So let's just review the one we did on Friday. We recognize this example. I'm gonna kind of just make a couple notes down here. We recognize this as something being cubed. And so that sort of made me think about, okay, well, there's something on the inside and it's being cubed. And so that's what made us realize that the outside function is x cubed, and the inside function would be what the something is. And in this case, it's 2y cubed plus 16y, right? Just sort of, so thinking about the two separate things, what's inside what, and then you differentiate them separately. And we went through that whole process, right? So I'm going to kind of highlight what we did, but then sort of, I'm trying to re-explain it in maybe a shortcut kind of way, right? So we identified f and g, and then we took the derivative of f and then plugged g back in, right? That was sort of those two steps. It was like a 1 and then 2-step thing where we took the derivative and then plugged g in. And then g, which is the inside function, we also need that derivative as well. And so when we sort of wrote down the final answer, it was this f prime with g plugged in multiplied by g prime. That's what the answer kind of ended up being. Okay. But notice, and there's a bunch of steps to that, and I'm going to kind of keep thinking about those steps. But the intuition that we should be trying to develop right now is this. When we have something cubed and we take the derivative of that, we just sort of ignore the something and take the derivative of the outside piece, right? So like, we just ignore what's on the inside, take the derivative of the outside, but then we multiply by the something prime, right? So you kind of ignore this inside piece. It's almost like the something just like doesn't exist in there, and you just take the derivative of 3x squared, or sorry, x cubed, and it becomes 3x squared. But then you remember, oh yeah, there was something inside there, and so I also need to just have that in there and multiply by that derivative. Right? So you're kind of ignoring what's in the inside and then accounting for it afterwards. That's sort of the general intuition we're thinking about. And I've just marked the heck out of this, so I'm going to erase basically everything I've written today. But just trying to help us think about how we're doing this. And I'm going to kind of reiterate that same thought process after every one of these examples. All right, can I clarify something about the chain rule before we jump into the next one? I'm going to look at the natural log one next, but I'm going to erase all this garbage that's on the screen right now. Anything? All right, so let me undo this stuff, go back to this space, just trying to think through that last example. And again, this example we will put on a new page in just a minute. But let's look at the next one. Let's look at the natural log one. So when I look at this natural log problem, it's a natural log with a 1/2 t inside of it, right? That's how we need to sort of start thinking about this one. So when I'm thinking about what's inside what, the outside function would be natural log, and what's inside of it, 1/2 t. Right, and that's a 1/2 t to the first power, and so it's like a nice easy power rule is what I'm trying to point out there. So you kind of identify the two parts, and then with the f part, it's like you're just ignoring what's on the inside, taking the derivative of just the outside part, so the f part, and then you plug the inside part back in. Right, that's how we're kind of thinking about this. Right, so with what we just wrote down in mind, you take the derivative of the outside piece, ignoring what's on the inside. Say natural log becomes 1/t. Let me just flash back to those derivative rules real quick. Right, the natural log rule, if that one's not in your brain yet, that's this one right here. Right, natural log just turns into 1 over the variable. And so that's what we just did. Right, f of t equals natural log. The derivative is 1/t. Right, so we kind of ignored the inside part, and then we say, oh yeah, but let's plug it back in. because there was something on the inside. So then we say, oh yeah, but let me go ahead and plug the G part back in. And it's a compound fraction, right? You're doing 1 divided by 1/2. And so 1 divided by 1/2 becomes 2. Right, so that's the first component, right? That's the outside component. You kind of remove what's on the inside, take the derivative, ignore the inside part, and then you put the inside part back in. And then, but then you need to account for the inside part because you kind of ignored it throughout that whole process, right? And so then you say, okay, but then I also need the derivative of that inside piece. So we take the derivative of the inside piece, which is just a power rule, right? 1/2 t to the first, nice easy power rule, just becomes 1/2. Or 1/2 t to the 0, if you will, which is just 1/2, right? And so those are the two components of the derivative. And so we'll stick those back in there in just a second. Let me just pause and see if there are questions. And I'll do this cotangent one on a new page as well. So we'll kind of cross that one out here. I'll write the answer kind of right over top of that one. Questions about sort of the pulling it apart part, kind of looking at the two pieces separately. We'll combine them in the answer in just a second. Anything?
How did you get 2 over t from 1 over 1/2 t?
Yeah, so if you have like 1 over 1/2, you flip this and multiply. This is how I usually think about it, at least. And so it becomes 1 times 2 over 1, which is just 2. Right, so this 2 is just doing this kind of thing. The other way to think about it is, right, if you have the number 1 and you divide it by 0.5, which is what you're doing, 1 divided by 1/2, it takes 2 of those to go into 1. Is that okay, or other clarificational things like that? That's the kind of algebra stuff that's just good to just clarify. Just get it right out of the way. It's okay. All right, so then let's write down the answer. So then based on this work tells us we're going to take the derivative of w, and I'm just going to write down the chain rule again. It's f prime of g of t times g prime of t. And we now have both of those components. So it's 2 over t times 1/2. And the 2's cancel. And so it's really just 1 over t. And that's the derivative of this one. I'm going to say kind of a summarizing thing, try to get people back on track if you're kind of getting confused about where we were, especially it's been over the weekend, maybe that your brain's not where it needs to be. I'm going to say something, but are there questions about the specific example that I clarify first? So if you've been kind of, if you haven't been closely following along or whatever, and you're wondering like, how do we get from something easy like the power rule to these kind of really complicated examples really quick? I just want to remind you of the progression. We've got all these rules, right? We've got all these rules in this list, and a lot of them are pretty straightforward, like the power rule. Like the power rule is not so bad, right? The constant function rule makes sense. Sine turns into cosine. That's not bad. We take all these simple rules and we apply them to more complicated situations where it's not just one separate thing, right? So the complicated situations are the ones at the bottom here that are in red. It's when we have simple things, but they're being multiplied, or we have simpler things, but they're being divided, or what we're working on now is sort of simpler things, but they're being plugged into each other. And so rather than having, infinitely many rules like, oh, what do you do if there's 1/2 t plugged into a natural log? Or what do you do if there's something inside an x cubed? Rather than having like infinitely many rules, we're trying to generalize these situations into breaking them down into their smaller, simpler components, which are listed previously, right? So like 1 through 13 for the most part are the simple ones, and then they get combined in these more complicated ones. But it really just boils down to the simpler rules is what we're trying to do. I know it looks complicated, but we're taking something that's complicated and reducing it to simpler rules is one way to think about it. Okay, so I just wanted to sort of get us back on track there if that wasn't clear. Can I clarify anything about these notes maybe now that you finished writing it down? The one we just did. Anything? Okay. All right, let's look at a couple more, and then I'm gonna ask you to maybe think about one or two. Yeah, let me do this last one, and then I'll let you think about the two that got crossed out. Right, so the f of t function here is clearly a sine function, right? And we have a rule for sine, but we don't have a rule for sine with some polynomial plugged into it. But we recognize it as that, right? It's a sine function with something else inside it that's a polynomial. And so that's how we think, okay, well then the f function, the outside function is the sine, and what's inside of it, I'm sorry, I didn't mean to write f prime, just f, is sine, and the inside function would be the polynomial part. And again, so we don't have the rule for this specific example, but we do have a rule for sine, we do have a rule for polynomials, and so we sort of break them apart, do those things that required by the rules, and put it all together. And this one's not too bad, right? Because sine just becomes cosine. Yeah, I'll just spread this page out. So the derivative of sine is just cosine, no big deal. And then g is a power rule, and so that's not a big deal either. Right, and then the g prime part, this is part of the answer. That's going to be the thing we multiply by. We need to take the f part, the outside part, a step further. And plug the g part back in. Right, so it's really cosine with the 2t squared plus 1, plus t, excuse me. And then we just put it together. Right, it's going to be the thing on the top multiplied by the thing on the bottom. So that's fine. Let's finish it. So based on this work, the derivative is going to be cosine of 2t squared plus t times 4t plus 1. All right, this is my f prime of g of t times g prime of t. I would love to answer a question. I just really think this is a good time to clarify something. I just don't know if people are just checked out a little bit, maybe just trying to get back into it. Maybe I know that feeling where it's like, I'm so lost, I can't even ask a question, but it'd be really good to try to muster something if you're confused. All right, well, if not, I'm gonna slip another page in here, like I mentioned, and we'll do these two that got X'd out. I think I can slip a page in here now that I've paid for this thing. Yeah. So let's just go right in there. Yep, blank page, great. So I'm just gonna copy those two back over. So it was, so from the last page, e to the 2x squared was one of them. And let's just put a line right here and we'll do the other one right next to it. The other one was cotangent of y squared. And so hopefully you can kind of see these ones aren't super complicated because it's like e to the x with something in there, right? It's kind of like the cotangent especially, right? We have a rule for cotangent and there's obviously a y squared inside there. Although I don't know if we've actually done the cotangent rule yet together. And so this is one you'll just have to look here, right? So here's the cotangent rule. When you've got cotangent, it turns into minus cosecant squared. So you have to think about that one. I think here. All right. I'm going to let you think about these yourself for just a minute, and then maybe we can split up and do some of the examples in breakout rooms is what I was sort of thinking about. No questions before we look at that? All right, so let me put these back up. Start pulling them apart and thinking about the two pieces. Oh, I was going to summarize the last one. Sorry, I wanted to just say one real quick thing about this one. In case you're still confused or you're thinking about how to simplify this, right? We don't have a rule for sine with something in it. So we instead realize it's sine. We know how to take the derivative of sine. So we kind of ignore what's inside it, right? That second part is totally ignoring the inside part. And we just take the derivative of the outside part. And then we say, okay, but we're going to stick the inside part back in. Right? So you ignore what's inside there, take the derivative, and then stick it back in. And then to account for the fact that you ignored what was inside there, it's one way to think about it at least, you look at the inside part, and then you take that derivative, right? And then you just put the two things together in your final answer. Right? That's sort of the simplified way. So you don't have to write down all this work and think about the formula and stuff. You're just ignoring what's inside there, taking the derivative, putting it back in, and then accounting for what's inside later. Okay, that's my sort of quick and dirty summary of the shortcut. Okay. Anyway, so you can kind of think about the same thing, right? It's an e to the x, but there's something in there. There's a cotangent, but there's something in there. All right, so I'm going to kind of write down the details, but see how far you can get by yourself, and then we can check the answers together. So when I look at this one, the outside function's e to the x, inside function looks like 2x squared. On this one, the outside function is cotangent. The inside function is y squared. Okay. So ignore what's on the inside and then account for it later. All right, I'm just going to stop there for a second and let you just think about how to finish that one off, and then we'll look at it together. I was trying to think if there'd be a good way in these situations if someone's like totally lost and they wanted to just talk to me one-on-one. Like usually when I ask people to do this, there's usually a couple of people who just don't even know how to start, which is fine. But usually in those cases, I'm able to they raise their hands. I'm able to come over and give them some one-on-one attention. I think if someone wanted to ask a question, I think we could just like shoot ourselves over to a breakout room, basically, if I'm not mistaken, while other people are doing that. I think I'm working on that right now. So anyway, let me know if you want to chat. Maybe we could pop over to a breakout room. Yeah, we totally could. So let me know. All right, I was just over in a breakout room with someone asking a question, so that was good. Yeah, that could definitely work in these situations. I'd like to start doing this a little more, giving you some time to think about this stuff. And popping over to a breakout room could be a good way to get some quick one-on-one help here. Let me see. Okay. Anyway, so let's look at this one. So hopefully you had some time to think about it. We break them apart into the two components, right? You take the derivative of f, just stays the same, right? That's the best rule out there. E to the x just stays e to the x, but you want to have g back in there. So f prime with g in there, it's going to be this, right? So that didn't change actually. So you're kind of having the same component, which is what happens when you have an exponential function. When you do e to the x and you take the derivative, it stays the same. But then you account for the inside piece with the g part, right? And so g prime is just a power rule for x. And so you have the two components right there, just multiply them together. Let's call this, what was it called in the paper? Is it called P or something? Oops. So P prime then is e to the 2x squared times 4x. We've got our f prime of g of x, got our g prime. Is that all right? Questions about that one at all? You guys get that? All right, we do the same thing with the other one or a similar thing. So I just need to remind myself of the cotangent rule, right? Cotangent becomes minus cosecant squared. So I'll have to drop down below. We have f prime times minus cosecant squared of y, but then we put the g back in. All right, so ignore what's in the inside, take the derivative, but then put the inside back in. And then g prime again, that's a nice, easy power rule. No problem on that one. Those are the two components. Just multiply them together for the answer, right? What is it? This was called h in the problems. This was h. So h prime then is this piece times 2y. Answer questions about it? Yeah, go ahead. Sorry.
For f prime of g, I did what you did, but was there a reason why the 2x squared went back into the exponent instead of just being in parentheses, like what you did for the negative CSC? Like, does it only go back in for exponential functions? It go back to the top instead of just being in parentheses next to it?
So it was in the exponent to start in the problem. I don't know if you see this, but this is e raised to the power of 2x squared.
Mm-hmm.
That's different than, so I guess I'm a little confused. That's different than cotangent. You can't just have cotangent by itself. Like you can't just have cotangent without anything in it. You need to have something plugged into it. So it's not like multiplied. It's not cotangent times y squared. It's cotangent at the point y squared. But you could have e times a number like 2, because e is a number. E is like the number 2.7. So e, you can raise it to powers, you can multiply it by things, you can divide it. But cotangent, natural log, all the trig functions and things like that, you need to have things plugged into them. So natural log is another one of those things, right? ln by itself is meaningless. It needs to be ln at some input value. Right, like ln, for example, looks like this. And so t would be the x-axis. And so you're saying at some t value, right? These are t vals. What's the output of ln? Does that clarify? Is that sort of the thing you were talking about? I don't know if that's
Yeah, calm.
so.
Thanks.
So maybe back to this example real quick. This was an exponent, right? It had e to the 2x squared. We took the exponent out just to think about the outside part. We took the derivative of the outside part, which just stays the same, right? That's a nice one. And then you just put the inside part back in, though. And so that's where, it doesn't get multiplied by that because we took it out of the exponent and then we put it back into the exponent. Other thoughts about either one of these? All right, so that's the chain rule. All right, we did 5 examples of that one because it's a tricky one, and that's why it has its own homework set with a bunch of problems, because it just manifests itself in so many different ways, and we just need to be able to recognize it in the moment. So that just takes practice, right? That's all. That's why this is just one of those topics where it's like practice makes perfect kind of thing. Whereas, sometimes if there's a formula or something, you just need to plug things into the formula a couple times and you get it. But this is like, there's so many different versions of the same thing in this. For example, let's slide back up to the last page. There's just a whole bunch more examples in the rest of the section, and I don't want to get too burnt out today. So I'm going to spend a little time on a couple of them. Probably let you do a few in breakout groups, and then we'll just do the same thing on Wednesday, and we can start digging into the homework on Wednesday too. So bring some homework questions that we can work on together as well. But this is the sort of the more examples section, right? And so this is more example number 1, but there's a whole bunch more on the following page too, right? These are all just more examples, and they all combine other rules. And so we're starting to combine rules, and we just keep taking it up a notch. All right, so let's start with this first one. I'm going to do this first one, then we're going to do some breakout groups with the other ones. So when I look at this first one, it's kind of complicated because if we want to do the derivative, we have 2 things being multiplied in the first thing, right? We have sine of 2y times e to the y. So when we do that derivative, we're going to need the product rule. And then when we take the derivative of the cosine part, it's a cosine, but there's something inside of it, and so that looks like a chain rule. All right, so we've got 2 of the things we've just been learning here. And I'm recognizing it as a chain rule and a product rule. And then also notice, I'll write this down in a second, but then when we start digging into the product rule with the sine of 2y in there is going to be a chain rule itself. And so we have a product rule and a chain rule, and the product rule has a chain rule in it. Right? They start to snowball. And the reason this is real stuff, because when you have real world examples of you're actually in a science, out in the field and you're making a function or you find something from the literature, they're not like nice functions. They're kind of nasty looking functions, and we need to apply the rules sometimes. All right, so I'm going to set this one up kind of slowly before I let you guys think about your own here. So when we start doing this, we're going to think about the derivative. How much room do I have there? I'm going to try to write it all down and cram it in right here. So we're going to do the derivative. I'm going to do the product rule. Should I color code this a little bit? I'm going to color code it. I'm going to change the product rule to a different color. Let's change it to blue. I'm going to try to color code this a little bit so when you look back at it, it kind of makes some sense. So the product rule is going to be in blue. So I'm going to write down the product rule. Right? The product rule says f prime g plus f g prime. All right, this is the product rule. I'm going to erase that arrow in a second, but you can see it's in blue at least, hopefully, so it corresponds to the product rule, right? And I'm doing f prime g plus f g prime. I don't want to keep flipping back between the tabs. Hopefully you can have that tab out. Look at the product rule and see if that's what it looks like. I can at least label it, I guess, right? So this is my f prime g plus f g prime. And then when we do the chain rule, for the second piece, it's going to be in purple. Right, so the second piece is going to be the derivative of the cosine part. And we'll need to do the chain rule on this one. Might as well just label this. Everything else is labeled. Is it okay? And I guess the thing I'm trying to point out here, the thing that makes this just another level of complexity, not only is it the product rule and the chain rule, but then when we do the d over dy of sine of 2y, that's going to be a chain rule itself. Right? Because we have a sine with something inside of it. And so as long as we're kind of careful about this, and I don't need to see all this work on a test, but this is the kind of stuff you want to write down so that when you go to the homework later, you remember the kind of things we talked about. So I'm going to look at some of the individual components real quick, but questions about how we're kind of dissecting that and thinking through what we're going to do? Oh, and let's just do the exponential rule too, right? And then when we do d over dy of e to the y, that's just an easy one. It's just the exponential rule, it just stays the same. So we don't have to think too hard about that one. It's okay so far? I'm just going to write down the individual things on the left here probably, and then we'll put it together. Right, so when I take the derivative of sine of 2y and I recognize it as a chain rule, I recognize the outside function as being sine and the inside function as being 2y. Right, and so then f prime with g plugged in is going to be minus cosine of 2y. And g prime is just a power rule, which is 2. And so you combine those things to get the answer. And I know we're going kind of quick here. It's like, oh, we just used the train rule and now we're just cramming it inside of this more complicated thing here. So I'm not expecting everyone to fully be on board here, but we need to start ramping up the complexity.
Why is it negative cosine 2y?
Because I messed up my rule. Sine becomes cosine. I always have a hard time remembering which is which. So sine becomes cosine, cosine becomes minus sine. Thank you. So it's just a positive there. So I just deleted the negative signs, guys. So there should be a plus right there. Plus right here. Yeah, so sine becomes cosine. Cosine becomes negative sine. I always mix those two up. So that's going to be that's going to go into the sine of 2y spot, right? That's just like one of the components that's going to go inside there. Happy to sort of go a little slow here and see if there's some questions about that. All right, let's just do the exponential rule real quick. I mean, not the exponential. Let's do the chain rule on the cosine part. So when you do the derivative of the cosine of 4y squared, we do a very similar thing, right? The outside function is cosine. The inside function is 4y squared. And this is where the negative sign comes from. When we do the derivative here, we get minus sine. And let me go ahead and just do the whole thing. F prime with g plugged in, you get minus sine of 4y squared. And the g, just a power rule. And so putting it together, that derivative is just those two things multiplied. So that's going to go into this part, right? And we have it all, right? We've got the components, e to the y just stays the same. And so we just kind of put the things in that are missing. Right, so final answer, p prime of y is going to be, we're just continuing. Let me go ahead and draw this line right here. We're just kind of bringing down what we had, and now we have all the different components. And maybe I can just slide this over into this nook a little more. So I'm just going to write in the individual components. So it's going to be cosine 2y times 2 times e to the y, sine 2y e to the y, and sine 4y squared times 8y. All right, I'm going to stop there. And I think I've changed my mind about what I'd like to do. I think I'm going to leave the group work and stuff till next time. So we've got an entire more page, an entire another page. I'm not going to scroll right now, but if you scroll to the next page, you'll see there's 4 more examples that are similar, that are kind of like combining product rule, quotient rule, chain rule together. And so we can spend some time next time doing that. What I'd like to do now is just turn it over to questions. If there's specific questions about homework problems or things on this page that people want to carefully go through, we can do that now. Or if some people, if you're really anxious to get out of here or whatever, I don't want to keep you over time this week. So you guys can let me know what you want to do. Are there, like I know Gregor started working on the homework. Have people looked at any of the product or quotient rule homeworks and are running into some issues at all? Or do people want to go there right now that we have a little more work under our belt with the stuff, and sort of see if they make sense or not? Just going to pause for a minute and see if anyone can come up with a question or not.
Can you just explain how you set up the product rule for the sine 2y times e to the y?
Yeah, so I was recognizing this as being two things multiplied, and I kind of threw a little multiplication sign in there right in the middle, right? I'm recognizing it as sine of something times product rule real quick. I'm sort of thinking about this product rule with this one being like the sine part, and this part being e to the y. And then I'm just trying to apply the rule to that. And so keep this in mind. Again, if you don't have this out in front of you, I've said it a million times, you really just need to get it out in front of you so you can reference it as we're doing this. I can't keep flipping back and forth, distracting the people. So you just need to have it out in front of you. And so part of the reason is you don't have that out in front of you and you're wondering why, and I don't mean anyone in particular, but like if you're having a hard time recognizing the product rule as being the product rule, it's because maybe you need that reference out so you can take a look at it. So with this in mind, and again, hopefully you have the product rule out, this kind of thing out in front of you, right? It's f prime g plus fg prime. And so when I flip back over here to this and I recognize this as being the product rule, I flip back over, and that's exactly what's going on. And I labeled the f prime and the g. Right? I'm trying to take the derivative of the first piece, leave the second piece alone. Leave the first piece alone, take the derivative of the second piece, right? That's what the product rule says. And again, I don't want to, well, maybe I'll flip one more time, but this is exactly what it says right there, kind of mapping it out on this problem. And then we start to go inside there and think about, okay, well, what are those individual derivatives? What's the f prime? What's the g prime? And start to think about what rules apply to each one of those cases. Does that clarify it? Can I say something else there? I see there's something in the chat here. I see a question about homework. That's good. I wasn't sure who just asked that last question, but is that okay? All right, Gregor's asking about problem 8 in that homework. So let me go ahead and see if I can pull that one up. Okay. Oh, so it's another equation of the tangent line question. Right, so let me just go ahead and write those things down. Number 1, you calculate the derivative. Number 2, plug in x equals 4 in this case to the derivative that tells the slope. 3, use this point to write the equation of a line. And if writing the equation of the line is still tripping anyone up, I've done it several times in class, and there's millions of YouTube videos about how to do that. That's, not only did we cover here, that's just something from a previous class that I know sometimes needs some refreshers, but at some point you got to just look at a different video if what I'm saying doesn't make sense. So anyway, those are the 3 things. And this is a product, it's a quotient rule, right? So when we do y prime, it's a quotient rule. And so we're going to, let me write out the details. It's going to be f prime g minus f g prime all over g squared. Right, so that's just the quotient rule. I just, that's one of the rules I just know. It's one of the common rules. Just writing this quotient rule out. I literally just wrote this thing out. Just wrote it out on the last page. Let's go back and make sure that that looks okay. All right, I've got my f prime g minus f g prime all over g squared. And they're all just power rules, so it's not too bad, right? And so then that derivative just is the derivative of 5x just turns into 5. 1 plus x squared just turns into 2x. Don't do anything on the bottom. Don't square that out. Just leave it. Right, and then you just plug in the number 4 to get the slope. And then you write the equation of the line. I'm not sure, I guess maybe we should keep going, or if that's sort of, if the derivative was the tricky part. Go ahead, Gregor, what were you gonna say?
It makes sense all the way up until there. I get it. Sorry. Thank you.
Okay, great. So we just did step one, right? This is step one. Step two is then to plug in the 0.4 or whatever your point is on your particular problem. And then you know, y equals mx plus b. This is the part, you know, I've said it a couple of times. I'll just say it at least one more time. If you have something, the line y equals mx plus b, we just found the m part, right? You can find the m part by plugging in x equals 4 into there. You'll get the m. You find the b by using your given point in x and y. So you have everything plugged in except for b, and that's how you find b. Again, take a look at one of the examples we did in the past if you want a reference on that. Or again, if you just like Google finding b and y equals mx plus b, you'll probably be able to find a nice YouTube video. Or Khan Academy or whatever. Other homework problems? Happy to keep talking about these things here or not. It's up to you guys. All right, well, I value your time and my own time, and so I'm happy to release folks, you know, a few minutes early, 15 minutes early, but we'll make up that time. All right, so I'm trying to keep one of the sessions a little bit shorter to account for the fact that one of them should be 50 minutes. So on Wednesday, maybe we can spend another hour and we could do some more practice problems. But the sooner you start looking at the homework and trying some of this, the more prepared you're going to be. I feel like if everyone leaves this homework until Wednesday night and they try to figure out all these rules on the spot while they're doing 30 problems or whatever, it could go pretty poorly. So I would just suggest looking at some homework, not completing it by Wednesday. Just look at it a little bit to gain some questions, write a few things down, figure out what you learn and what you don't, and then we can spend some more time on Wednesday. I'll stick around in case anyone wants to talk some more, but otherwise, thank you very much.